Let's discuss the problem of an unwinding cable. A light cable is wrapped around a solid cylinder. A light cable is wrapped around a solid cylinder with mass m and radius r. Then the cylinder rotates with negligible friction about a stationary horizontal axis. The free end of the cable is tied to a block of mass m, and the block is released from rest at a distance h above the floor. So as the block falls, the cable unwinds without stretching or slipping. And then the question is, what's the acceleration of the falling block and what is the tension in the cable? So here's the free body diagram for the block and for the pulley, the cylinder, which is a pulley right here. The block itself is under the action of two forces, tension force directed vertically up and the weight of the block directed vertically down. And so for the block, I will apply Newton's second law. For the pulley itself, we have tension force. That's the only force that acts on the pulley and makes it rotate. So therefore, I can use the second law form for rotational motion to find information about the acceleration and the tension force. Selecting my vertical axis to point straight down for the block, Newton's second law is written as mg minus the force of tension is equal to ma. The problem here is that I want the acceleration, but also the tension force in the cable, and so I cannot find the answer by having only one equation. So therefore, I also must consider Newton's second law equation for the pulley. So for the pulley or cylinder, the torque of the tension force, T times R, is equal to the moment of inertia of the pulley times the angular acceleration of rotation of the pulley. From here, I can write an expression, rearrange the terms, and write an expression for the tension force. So we've done this already for a different type of force, and that was the force of static friction in the case of a sphere rolling down the incline. So the expression for the tension becomes IA divided by R squared. Notice that here we do not have negative sign in front of the expression because the center of mass of the cylinder is stationary, it's not moving. So there is no direction for the acceleration, so I can go with plus sign. The moment of inertia of a cylinder is mr squared over 2, and so replacing that in the expression for the tension force, I get mr squared times a divided by r squared. So I can cancel out the radius to the second power in the numerator and denominator, and finally get an expression for the force of tension in terms of mass acceleration. And I forgot to add a 2 here. Okay. So this is the tension force in the cable. Now I can take the expression for the tension force and go back into the second law for the block, substitute in there, and then get an expression for the acceleration of the block. Just 1 second. Stay there for 1 second. Just want to say these words, okay? All right?
First of all, when are you going to make the mixture?
Soon. I'm busy right now. Like, until I'm done here, I'm not doing anything. Probably at 4 o'clock.
I love you.
I love you too.